In this section, we'll learn methods for solving several other types of equations, specifically polynomial equations, radical equations, and absolute value equations. We'll start with polynomial equations. A polynomial equation is the result of setting two polynomials equal to each other. The equation is in general form if the one side is 0 and the polynomial on the other side is in descending powers of the variable. Highest exponent on the variable is referred to as the degree of the polynomial. In this section, we'll only be solving polynomials that can be factored. In sections later in the semester, we'll learn how to solve a polynomial equation that cannot be factored. We'll be using the factoring methods that we reviewed in the last section, especially factoring by grouping and greatest common factors. So just a couple quick examples of things that are polynomial equations. So something like 3x squared plus 5x plus 2, we called that a quadratic equation last time. That's considered a polynomial equation. The degree on this would be 2, and it's in descending order because we have exponent of 2, 1, and then none. Okay? Or something like 3x minus 5x to the 4th power plus 2x squared minus 9x cubed equals 4. Okay, that's a polynomial equation as well. Here, though, it's not in descending order. Highest degree is 4. Okay, the thing that makes a polynomial is that all of the x's have these nice whole number exponents. Okay, so a couple things that would not be polynomials. Okay, the square root of x plus 5 plus 4x equals 1. That's a radical equation. X is contained within a square root, which means it doesn't have a whole number exponent. Okay, or something like 5x to the negative 3 power plus 2x squared equals 4. Okay, that one we have a negative exponent. So again, the thing that makes a polynomial is whole number exponents. So let's go into example 1, which says solve by factoring. So example 1a, we have 4x to the 4th power equals 12x squared. So similar to quadratic equations when we factored, we want to make sure we have all of the terms on the same side, factor, and then use the zero product property. So we'd want to start by subtracting 12x squared on both sides. That gives us 4x to the 4th power minus 12x squared equals, on the other side, 0. There's only two terms here, so we want to think about factoring by the greatest common factor. If I look at my numbers, 4 and 12, those are both divisible by 4. And x to the 4th power and x squared, I can factor an x squared out of both of those. So if I factor 4, if I factor a 4 out, I'm left with a 1. X to the 4th, factor out x squared, we're left with 1x squared, or just x squared. A positive and a negative will result in a negative. 12 divided by 4 is 3. And x squared, if you factor out x squared, the x's are gone. Okay, so now that you have factored, you can apply the zero product property, just like in our quadratic section. So we would say 4x squared equals 0, and x squared minus 3 equals 0, and we're going to solve both of those. Okay, they're both set up as quadratics with no x term, and so we can use the square root property on both of these. If we divide 4, x squared, 0 divided by 4 is 0. And if x squared equals 0, x would equal plus and minus the square root of 0. Well, the square root of 0 is 0, and positive 0 and negative 0 is the same thing. Okay, this one, if we add 3 to both sides, x squared equals 3. And if x squared equals 3, square root property says x will equal positive square root of 3 and negative square root of 3. 3 is not a perfect square, and the only factors of 3 are 1 and 3. So our solution set is 0, square root of 3, and negative square root of 3. Example 1b, we have 2x cubed plus 3x squared equals 8x plus 12. Okay, so here we have 4 terms, and the type of factoring you should think about whenever you have 4 terms is factoring by grouping. But again, first thing is, in order to factor and use the zero product property, you need everything on the same side of the equation. So let's subtract 8x and subtract 12 to eliminate them on the right-hand side, giving us 2x cubed plus 3x squared minus 8x minus 12 equals 0. 4 terms again, so you should think factoring by grouping whenever that happens. We've got the first 2 terms and the second 2 terms. 2 and 3 don't have a common factor, but x cubed and x squared, we can factor out an x squared out of those. So if we do that, we're left with 2x from our first term. And if you factor x squared out of 3x squared, you'll be left with just 3. Our second group, negative 8 and negative 12, those are both divisible by 4. And to have 2 positives after we factor, let's factor out a negative 4. And not both of them have x's, so we'll just factor out a negative 4. Negative 8 divided by negative 4 is positive 2x, and negative 12 divided by negative 4 is positive 3. Remember, the key for factoring by grouping is that these 2 groups should be identical. So now if I factor that like parentheses to the front, if I factor 2x plus 3 away, I'm left with x squared. If I factor 2x plus 3 away, I'm left with minus 4. Now that we have factored, we can use the zero product property to say 2x plus 3 equals 0 and x squared minus 4 equals 0. So solving both of those, 2x plus 3 equals 0, we would subtract 3. 2x equals negative 3. Divide by 2. X equals negative 3 halves. X squared minus 4 equals 0. I would want to add 4 to both sides and use the square root property since there's no x and we have an x squared. If x squared equals 4, x would equal the square root of 4 and negative square root of 4. The square root of 4 is 2. So we have 2 and negative 2. So our solution set, negative 3 halves, 2, and negative 2 in no particular order. So if you switch the order around, then that is perfectly